All right, let's get started. So, the big thing from the 3D shape is what really builds the shape up to be what it is. And it kind of touch on that. We're starting first with cross sections. And cross sections are a face or surface of the shape or of the 3D shape when cut. So when we're talking about cross sections, we're talking about the space or the shape that's made and we slice into it, kind of like when you slice in a butter, an orange, a lemon, things like that. So I found a really good way to help us visualize this online, and I will link that with specific links in this video for later. But we're going to go over a couple different things. We're going to be looking at individual shapes, like cones, rectangles, pyramids, etc. But we're going to be looking at what different types of cuts do to our cross sections. So we're going to be looking at horizontal cuts, vertical cuts, and diagonal cuts. Because we can slice through images in 3 different ways, and how we cut through that 3D image affects the cross section that we get out of it. So we're starting with a cone, and we're looking at the horizontal cut first. So let us see. Sharing our web. First, we'll look at sections of the cone. So right away when I look at the cone, I can see that my horizontal cut is made in my shape. And how I can tell what the shape is in this little tool is I can actually rotate it upwards. And what we can see here is that if I cut through a cone horizontally, I actually get a nice circle shape right here. So when I make that horizontal cut, you get a circle as your cross section. But what if I were to rotate it, take a look at it vertically? And that's where these sliders on the side really come in handy. When you have these sliders on the side, you can actually play around with it until you have the plane that it's cutting through just as you need it. And if I look here, I'm rotating it all around, so I can actually mess with for this. And I can see that my cross section goes from being a circle to actually being a triangle. So for a cone, you cut horizontally, you get a circle, but if you cut vertically, you get a triangle. You know, 2 different cuts give me 2 different faces, but what if I cut it diagonal? And just kind of make sure it cuts in a funny way. About right here. And if I cut right about here, giving myself some space on the base of my prism or my cone, I sometimes get a circle. See how it's elongated right here? It's actually not perfectly round. You get something that's kind of slopes up to the side. What we call this shape in math, when we have a circle that looks like it's pulled out a little bit, is we call that an ellipse. So it's spelled E-L-L-I-P-S-E. E-L-L-I-P-S-E. There are also multiple different diagonal cuts you can get here. This one's the most varied. Watch as I play around with the slider a little bit on the shape. You see how it starts with that circle? If I pull it through, it goes to an ellipse. I'll just pull an ellipse and here's just that edge. That bottom edge right there is where this ellipse shape is going to go away. Watch I pull it further towards vertical, and I'm actually giving myself a nice flat line right there. I'm giving myself an edge in my cross section. We don't really have a name for this. Most of the time when you see something like this, it's just half of the full image. So you can call this a half ellipse. in your notes if you're doing something like this on your homework. As you pull it further and further, you can see that image starts getting more and more tall. Starting to sharpen up a bit at the top and go straight to the vertex. And that's what we have for our cone. So going back to the paper, we have three different things. For a cone, when you cut horizontally, you get a circle. When you cut vertically, you get a triangle. And when you cut diagonally, you get an ellipse. On your notes, I still recommend you drawing these out. Even though you will have the online tool for later, it still helps you to see this on paper as well. And when you actually start drawing it out on your own, it really helps solidify this information. So if I do a horizontal cut, that's where my circle comes from. If I do a vertical cut, that's where my triangle comes from. And diagonal stays in the list. Notice so far that our faces seem to match what's parallel to it. When you have a horizontal cut, it's a circle, and the face of our cone is a circle. When you have a vertical cut, even though the triangle or the cone is round, if you look at it head on, it has a triangular shape. So if I cut vertically, that means I should get a triangle. Keep this in mind as we continue through. Now for a rectangular pyramid, we're going to repeat the same process. We're going to do a horizontal cut, a vertical cut, and a diagonal cut. And draw the picture again. The easiest way to do a rectangular pyramid, I recommend extending the sides. They'll be a little bit easier to see in your notes. So kind of like this, just so I don't confuse it between a square pyramid and a rectangular one. Once you have your rectangle drawn, connect all points together, just like this. Now that I have my list all ready to go and my pyramid all drawn out, I'm going to pop back over to that thing and play around with it. So let's try the rectangular pyramid. What does that mean when we have a rectangular pyramid? Well, automatically, looking at it, my theory is holding true right now, right? I can see right here my horizontal cut that I actually have a rectangular cross section right here. Again, a rectangular cross section that's matching its parallel base, that is a rectangle. So that means for your horizontal cut, you get a rectangle cross section. And this one might be a little bit easier to visualize for the vertical. Again, look at the vertical face right here. Now look at this pyramid head on. Pretty easy to tell that I have triangular faces on every single side. So if I flip this all the way to vertical, and I move that a little bit more, just so it's perfect on my vertex, what do you know? My cross section actually matches up perfectly with my face. So that means the horizontal is rectangle, and your vertical is a triangle. Now the final one is the diagonal. If you want to do diagonal, we're just going to rotate it a little bit. How about here? Let's look at the shape again. Let's play around with this shape before, and this dark yellow patch right here. We have a four-sided shape where my tops and bottoms are parallel, and it looks like that my left and right sides are congruent to each other. This means that when you have a diagonal cut in a rectangular pyramid, you have an isosceles trapezoid. So we have three different shapes that exist in this image depending on where you decide to place it. Horizontal is a rectangle, vertical is triangle, diagonal is an isosceles, trapezoid. So let me go back. Take a look here. I'm going to draw it again on my shape just so I can see it. That the rectangle exists horizontally in this pyramid. That my triangle also exists in here. If I cut vertically through, and then isosceles trapezoid does as well. This is what I mean when I say you want to have something like the GeoGebra. That's what I'm playing around with, because drawing, while awesome, can get really messy really fast. So when I link type to you guys online, be sure to use it. Let's give a try to the triangular pyramid. This will be the last one where we use the agate first before we make our decision on what the cross sections look like. And then we're going to start making our assumptions and backing it up using our tool. First things first, set up your list with horizontal, vertical, and diagonal. We're going to draw it out. In a triangular pyramid, you have a triangle base. And it all connects back up at one singular vertex. You're going to have your list set up as horizontal, vertical, and diagonal. And you should have a big enough image to draw in right next to it. I usually draw bigger, typically because it's going to be messier and I want to make sure I can read these later. But if it's good with smaller images, be good with that. Do what works best for you. Let's go ahead and move on to the triangular pyramid. See what we get out of it. So first things first, taking a look at it again, automatically you can tell my base is a triangle, so my parallel cross section is also a triangle. Your first list for horizontal should have triangle as your cross section. Next is vertical. That means in this tool, we'll rotate it back up, and I'm going to go ahead and flip it to vertical and move it a little bit more so it's meeting my vertex. And again, my sides are triangles, so under that assumption, that means that I should have anticipated my cross section for vertical to also be a triangle. So far I have two of the same answer. And it seems that if my horizontal is a triangle and my vertical is a triangle, I'm going to make the assumption right now that my diagonal will be as well. So if I rotate back, once I give myself a little bit more of an aerial view, rotate it, and look here. It's not changing. It's maintaining that triangular shape all throughout when I go back towards horizontal. So this means that in a triangular prism, your horizontal cross section is a triangle, your vertical cross section is a triangle, and your diagonal cut is also a triangle. We have three of the same shapes that exist in this pyramid. So going back to our paper, draw that out. Your horizontal cut is a triangle. Your vertical cut is a triangle, as well as your diagonal. So now with this information that we have, we can start making assumptions. We're going to write these assumptions below. We can assume that all parallel cross section, and faces, or faces is the better word, all parallel cross sections and faces must be the same. Must be the same shape. So this is the assumption I'm going to roll with as we move through our notes. All parallel cross sections and faces must be the same shape. And it's something that's actually proven with this tool that we've been going through. So let's move on to triangular prisms using sphere and rectangular prisms. We're not going to rely on the tool first this time. We're going to make our list, we're going to draw the faces, and then we're going to check to see if we're correct. So in a triangular prism, we're going to be looking again at its horizontal cut, its vertical cut, and its diagonal cut. So let's draw that triangular prism. Remember, when we're working with a prism, I'm going to give a top shape and a bottom shape. So that means your top face is a triangle, and the bottom face is also a triangle. Something like this. Which is a little bit closer so you get the picture. So, again, my rule is that the cross section must match the parallel base. So if I cut horizontally here, if I cut through horizontally, I should be given a triangular cross section. So I'll write that down. And vertically, if I decide to cut vertically through this image, since my vertical sides are all rectangles, that means that my cross-section face should also be a rectangle. Now the diagonal is trickier. Since the diagonal is moving from triangle to rectangle, I'm going to take inspiration from the rectangular pyramid. In our rectangular pyramid, we said that the diagonal here was an isosceles trapezoid. So taking that, that means if I cut diagonally in the shape for the prism as well, I should also get an isosceles trapezoid. So we have our guesses. Let's take a look. Let's give the triangular prism a try. So starting off, take a look here. Already I can tell my horizontal cut is definitely a triangle, which means our first guess is correct. Now if I rotate this, again, my vertical face is a rectangle. That means when I cut vertically through the prism, I should also get a rectangle as well. Now this depends on whether it's further up or further back. Your rectangle shape can actually change, but it'll never not be a rectangle. You see that right there? How it goes from really, really small to really, really big. And like I said, it's always a rectangle, no matter what. Now, diagonally, I assume isosceles trapezoid. And it looks like that is the case. Look how it bends upward. So again, you may not have it be the same length every time, but you will always have an isosceles trapezoid of some sort until you hit that vertex right there. Let's think about where is the research and the time to come back. So in all reality, you could have two here. That depends on where your cross section is. So for now, let's think about isosceles trapezoid, but be aware, the further up it goes toward that top vertex, the closer it becomes to being a triangle. Let's move on to the rectangular prism. Just like the triangular prism, the rectangular one means that it has the all rectangle sides. Here we go. Another rectangle, maybe as well here. Try to do it a little bit more straight for you guys. Now this one, I can actually look at this. We may not even need the tool. For my horizontal, if I cut horizontally through this, well, the top and the bottom are rectangles. So that means my cross section would also be a rectangle. If I cut vertically through this, I wanted to cut vertically through this shape. Since my front and the back of this shape are rectangles, means you would get another answer of rectangles for your cross section. The tricky part here is the diagonal. Let's leave this one blank, then we move on to look at the next part. So looking at rectangular prisms, I could tell already my horizontal is a rectangle for sure. If I were to rotate the vertical, I get another rectangle. Now, diagonally, if I want to rotate this to be diagonal, I still maintain that rectangular shape all throughout. No matter what, you will always have a rectangular shape when you cut through a rectangular prism. So just like when we talked about the triangular pyramid, where every cross section was a triangle, for this one as well, when you cut through a rectangular prism, every single cross section will always be a rectangle. So let's go back and let's start on cubes. Now, cube is an interesting one. Again, when we refer to cubes, we're referring to a 3D shape where every side is a square. Every single side in a cube is a congruent square. With that in mind, every side here is the exact same. And the pattern tells me that no matter what, if every single side is the same, if you have all the same type of faces throughout your image, then every single cross section will be the same shape as well. In the rectangular prism, every single side is a rectangle. No matter if the sides are congruent or not, there's always going to be rectangles on the side. So that means no matter how I cut it, that's the cross section I get. So if I look at the cube, every side here is a square. So no matter how I cut the cube, that means every side or every cross section is a square. And that's all you need to know. If I cut horizontally, I get a square. If I cut vertically, I get a square. And if I cut diagonally, I would have gotten a square. The next interesting one is a sphere. Now in a sphere, we have our horizontal cut, our vertical cut, and our diagonal cut. And a sphere is just one big circle. Imagine like that for more uniform, you know what I mean? So draw one next to your list right here as best you can. And the best way to illustrate what a sphere is, there's a little dotted line in the back to help give it some dimension here. And when you do that, you're automatically telling yourself something. When you add those dimension lines to your figure, you have created inadvertently a horizontal cut. What this is telling me is that this whole there's a horizontal cross section that exists here, and that is a circle. And this can be repeated up top as well. If I did that 3D line up here, I would get another circle face. And again, the pattern still holds. If my horizontal cut and my vertical cut both produce the same shape for the cross section, that means your diagonal also has to be that way as well. So in a sphere, all different sides must be a circle. Let's play around with that. Again, automatically, I'm looking at this. My horizontal cut is a circle. No doubt about it. I'm just going to rotate it through because the sphere is pretty easy to see. And as I rotate, you can see the circle still exists no matter what. I can move it all the way to the top. I can rotate it. Circle still exists. I can rotate it all the way to the bottom. How about right here? And if I rotate it, it will circle. No matter what in the sphere, even though it's a round 3D shape with no real circle face, any cut you make will always be a circle. Even if it looks almost impossible with how much shape or space there is on the bottom, like here, the cut will always be a beautiful circle. Last but not least, we have a cylinder. Yeah, you take a cylinder, you take your can of beans, and a huge, even the big hominy ones you can find at the stores too. Cylinders come in all beautiful shapes and sizes, so it help us get our food. So they got that beautiful top, got these nice long walls, and then a circle bottom. In a cylinder, we can still cut it apart. We have horizontal cut, vertical cut, and diagonal cut. And for the horizontal, you would have a rectangle, your vertical. I apologize, your horizontal would be a circle because it matches the base. Horizontal is circle, vertical is a rectangle, and your diagonal. If I were to cut diagonally through this, you would get somewhat of an odd shape. Let me show you what that would be. So in a cylinder, when you cut diagonally, it maintains itself as a circle until the very top. Remember that word I taught you at the beginning of this unit, and you have a circle but not quite? These are elongated circles and have the official name of ellipses. So that means your horizontal cut in a cylinder is a circle. Your vertical is a rectangle, but your diagonal is an ellipse. So let me show you what that would mean. If you cut horizontally, you get that beautiful circle. If you cut vertically, you get that beautiful rectangle. And if you were to cut diagonally, you would get an ellipse, just like that. So see, there are 3 different shapes that transition into each other that help to make what this 3D image is. And that is all for cross section for today.